Current, up to current we are done, right? So today Amar is done, Akbar is done. Today we will be introducing ourselves with Anthony, and Anthony's name is resistance. Okay, so let's start. Okay, so topic for today is resistance. Topic for the day is resistance. So there was a person, and his name is Om. Okay, Om. So the full name I'm not remembering. So he did a couple of experiments. He carried out a couple of experiments, and these experiments were conducted for conductors. And in this chapter, whenever we say conductors, we are actually referring to metals. A couple of experiments was done, and these experiments were done with conductors. Okay. While these experiments were done, there was some care taken that the temperature variation was taken care of, so there can be no temperature variation. And there is a term called other physical properties. This typically means to the geometry. What do you mean by the geometry of a conductor? The size, the length, the thickness. So he did not actually vary these two. Means he has taken some conductors and he has taken shapes of those conductors. Let's say the shape is something like a small cuboid, or it could be a cylinder. So if I'm taking a cylinder of say X cross section, X radius and Y length of a metal A, for metal B also I'm taking a same cylindrical piece, X and Y. Metal C also I'm taking X radius, Y length, and all those are being tested at the same temperature. It's not that you are testing somebody at temperature T1 and somebody at temperature T2. These two are very important, and the importance you will understand in grade 12. Temperature cannot be varied, and other physical properties will not be varied. So the two crosses that I have put, instead of two crosses, I will say temperature and other physical properties remaining the same or no change. Okay, you won't do any change in these two things. And he started some experiments with conductors. The conductors were metals. Understood? Our gentleman found out that the current flowing through a conductor, was found directly proportional to the potential difference maintained across the conductor. Now, all these things you will find very mugging up sort of oriented. So let us try to see. First thing, let's try to see it in pictorial manner. Then we'll try to define. Okay. So let me rub this and let me make my simple drawing, which will try to explain this thing. So let's say this is a conductor, all right? And on this conductor, so this is a conductor, and this conductor is subjected to okay. This is plus and this is minus. First understand, then your definitions become easy. We are talking about conductors. So, and our chapter is, we have already discussed about something called current. So if you talk about current flowing in a conductor, you are actually talking about free charges. A current can flow only when there are free charges, right? Free charges are the ones which can move, and get your concept correct, which can move. So again, one more drawing just to understand this. Let's say I have a piece of conductor. This is a piece of conductor, and I have a piece of insulator. Right? Whenever you will be subjecting these two to some electric field, like you have a gravitational field, a body is attracted in that field. So if you give an electric field, though not in your syllabus, the word electric field is not there. If you give electric field, then that charge carrier will experience a force. Like in a gravitational field, anybody who has mass experiences a force. So in an electric field, anybody who has charge will experience a force, and they will try to move along the direction of the field. The Earth's field pulls you in way, therefore you come towards the center of the Earth. Now, in the case of insulators, though there is an electric field, means you are applying electricity, there are no free charge carriers. Are you understood? So it's like, the concept is like an atom. An atom has got a nucleus where you have the positive charges which are bound. Protons can never move, but electrons can move. These electrons are of two types in case of metals. One are called free electrons and one are called bound electrons. Bound electrons are the children who are sitting in the lap of the mother. They're not allowed to cycle in the colony and all. The free electrons are the ones which will be moving. In the case of metals, you have bound electrons as well as free electrons. In insulators, we don't have free electrons. So no free electrons means no sort of movement. So no current is seen. Do you understand? But in the case of conductors, we have got free electrons, and whenever we'll apply any electrical signal, these free electrons will experience a force and they will be moving along the direction of the force. Is this much understood? Okay. Now, if you have slight bit more of doubt on this, if there is a little bit more of doubt, then let's understand one more thing, one more concept out here. So you have an atom, and the atom has left its free electrons. Now what does the atom become? The atom becomes a positive ion. Is this concept understood? This positive ion also has electrons with it. Totally, say, suppose, let's say aluminum. Aluminum has got 3 electrons on the outermost shell, right? The rest of the electrons are all tied. So in this ion, there is a net positive charge, and these fellows remain fixed. Have you understood? These remain fixed. Let's first understand how current flow happens. So let's say this is a conductor, and think that there is no battery connected to it. It's a idle piece of conductor here. So the idle piece of conductor will contain what? It will contain some free electrons. Is this understood? And there will be some fixed, what do you call, positive ions also. What are these positive ions? These are basically the atoms from which these electrons have parted out. And the free electrons are like chapris. So what they will do, they have a property in which they will get attracted to these positive charges no matter. So they undergo a random collision. Somebody might collide, somebody might have a collision on this side, somebody might have a collision on this side. There is a motion. Somebody might get collided on this side, somebody in this side, somebody is getting collided on this side. So there is a random collision happening. Everything is in motion, but there is a random collision. Let me put another thought to it. Suppose there is a party which is happening in a banquet hall. There are a lot of people. Are the people not moving? They are moving. Somebody is holding a glass of drink and he is moving to that table to take a piece of snack. At that time, somebody is moving to the other table. So don't you think their motions are cancelling each other? So if you see holistically, as a bird from a high view, do you see a lot of people getting out of the banquet hall? Or do you see the people in the banquet hall moving in one direction? No. They are having movement within themselves, but those movements are in average cancelling each other. So what about the average motion? 0. If there is no motion, then there is no current. Is this understood? So if a conductor is lying alone, there will be free charges. These free charges will move, but this motion is known as random motion. Okay, this motion will be known as random motion, and we can actually बैठ गया यहाँ पे अभी 1 minute है children. Yeah, okay, these motions will be random motion. So just a little bit of high level, but you can understand a conductor just left alone means there is no external connection to it. Then here we will say average moving velocity of free electrons is equal to 0. So there is no current in that conductor. This concept you will study in grade 12. Have you understood? Yeah. So continuously they are moving, they're having random collision, but you don't expect them to move in a straight line where they're passing out of this conductor. I told you, the people inside a banquet hall, they're moving, but you don't see a stream of people entering a banquet hall and getting out of the banquet hall. Have you understood? So if the conductor is left alone, then there will be free electrons and there will be movement, but the average movement is nullified. Have you understood? So no electron is said to move with a velocity. But in the case of an insulator, first of all, there is no free electron at all. So in the case of an insulator, there cannot be any movement, not even that random movement. Clear? Now what we have done, we have taken the same conductor and we have given it an external potential difference, voltage to it. Okay, and this is maintained by someone who is known as a, say this is my battery. The battery is a combination of cells. Imagine that this is a battery, and the battery is creating a potential difference now. Obviously, this side is always the higher potential and this side is always the lower potential. Is this understood? Now, who is the charge carrier in the case of a conductor? Electrons. So we again go back to our story of 1800. So let's bring some electrons. So don't you think that an electron will actually get repelled from this direction, right? Then the electron goes here, then this electron goes here, the electron goes here, this electron goes here, then the electron starts to travel because slowly it is seeing a positive charge on this side. Slurp, slurp, the electron travels, the electron is traveling, the electron travels. And here it will be coming with the most amount of love because a negative charge is getting a positive charge. Question arises. It has to move. How does it move? Imagine the electron to be a small baby. At this junction, the battery has created a potential difference. The baby just slides. The baby just slides, higher potential to lower potential. So what is the job of a battery? You should understand this. The battery does not give birth to electrons. The battery is an electron pump. Whenever the electron comes here, have you seen children doing merry-go-round? One of the nursery teacher will be a come, go, run. So that's the job of the battery. If she stops doing that, all the children stop. The current stops. Have you understood? So that's how the current is actually moving. Now, this particular battery creates a steady potential difference. Steady word is very important. If it creates a steady potential difference, then this slope is very steady. So it's just like nursery children, one after the other going down. You will see them moving with uniform velocity. However, if you keep changing this, slope, what will happen? This voltage difference won't be steady. So the current that you will get will also be unsteady. But in our what you call syllabus and all, we study only steady current. Have you understood? Let's see one more example before we get into Ohm's law so that our all concepts become clear. So is the concept of current flow in a conductor when it is connected to an external source clear with you, how the current flows? Let us see one more interesting phenomena that happens naturally. Grade 8, some natural phenomena. So lightning. Let's say there is lightning, there is a tower out here and a lightning has taken place. The charges are actually moving from here to here. Does this constitute a current? Yes. What is the difference between this? We don't know how much amount of charge is going to come. For how long will it come? But this current is very strong. Yet we can't utilize it for any of our use because first of all, we don't know. Then we don't know how much it will come. Right? My particular clock is designed to run with a 1.5 volt battery only. So tomorrow if I connect my clock, I don't know 1.5 is coming or 1.5 millions are coming. This is unsteady. What we are going to study is all about steady current. And the biggest thing is there, this is occasional. Man chaha to hua. But here you have kept a battery. That's the job of a battery. A battery's chemical reactions will continuously create a potential difference, which in higher classes we call as electromotive force. What force? Electromotive force, a force which gives motions to the electron. The day the chemical reaction ceases, the electromotive force ceases and my clock stops. I need to go to the shop to buy another new battery and replace it. Is this clear? Right. So what Ohm did, now since our idea about flow of electrons and all are correct, Ohm actually maintained, see, you are actually giving a potential difference. You're maintaining a potential difference. There's a difference out here. Say you're maintaining V out here and you're maintaining 0. So there's a potential difference of how much? V minus 0. So we don't write it like that, but just understand that a potential difference. Now, at different potential difference, he's trying to measure what is the current across it. So our diagram needs to be a little bit more better. So how do we make our diagram a little bit more better? And this you are supposed to do in higher classes. In our grade 10, we used to do this as a part of what you call lab experiments also. So in order to maintain the potential difference, what we will do? We will connect a voltmeter out here. So the voltmeter is going to tell me how much is the potential difference, right? We can connect the voltmeter here also. It's similar to connecting the voltmeter here. So let us do one thing. Take the voltmeter out here. So 1 minute. Try to understand, because if you draw now, I would be changing my diagrams a lot. So you might find that, every time he's changing the diagram, I'm changing the diagram to make you understand. So pay more attention to understand. So I have a voltmeter now, which is connected here. So the voltmeter is measuring how much is the potential difference across the conductor, right? I should also measure how much current is going through it. So I need an ammeter also. You can put the ammeter anywhere, because if you think it like water, it is actually going in only one line. Sir, from here the water can go here, but this is a high resistance component. Therefore, the water can never flow into this direction. The water will be flowing only in this way. So where do I put my ammeter? I can put my ammeter out here. I put an ammeter, right? Okay. So what Ohm did, he started changing this voltage and he started to observe what is the change in current. For majority of the conductors, he found that the current is behaving proportionally to the voltage. Means if the voltage increases, the current also increases. And start thinking, if you create more slope, don't you think the children will slide and go more faster? And the faster the children go, the faster is the current. After all, what is current? Rate of flow of charges past a cross section. So he is increasing. And if he reduces, the children go slowly. So Ohm found that for majority of the conductors, the current that flows through a conductor is directly proportional to the voltage difference that you maintain across it.
Bigger the battery, the faster it.
Bigger the battery means the bigger the voltage potential difference that we maintain. The potential difference is created by the battery. So more potential, more voltage you give, more will be the current that will be running through the conductor. As such, the conductors who actually followed this particular, not all, majority of them. So he called those conductors with a special name called ohmic conductors. So your grade 10 will say for a conductor, it's not true. Not every conductor will behave like this. There are only a certain class of conductors who will behave like this under this condition. Those conductors will be known as ohmic conductors because they follow a law which will be given by Ohm. That's what we are, which is known as Ohm's law. So Ohm found that the voltage applied across, the current flowing through a conductor is directly proportional to the voltage that you maintain. Now, since this is what you call a proportional expression, we can introduce a constant of proportionality out here and multiply this with I, and that constant of proportionality is represented as R. So we say that V upon R is I is always constant. This is grade 8 stuff. Have you understood? V is directly proportional to I means V upon I is always. This is directly proportional. This constant is given the name of resistance. Resistance. So start thinking. Resistance. What does the word means? Something negative. Something negative from literature perspective. Resistance. This person has got a lot of resistance. कुछ भी बोलो नहीं करना चाहता है. कुछ भी बोलो नहीं करना चाहता है. So what is this resistance to? This resistance is to some obedience. What is that obedience? I let the charges flow. Doesn't allow you to flow. So what do you say? प्यार से बोला नहीं जाता है. So what do you do? You start screaming. Your screaming is like increasing the potential difference. At that time, the charges are easily about to make their way through that conductor, right? So if you see this constant, which is a constant of a ratio of V upon I, it is called resistance, means it offers a resistance to the flow of current. I need to overcome it. Therefore, I say the more the potential difference I apply, the more is the current that I see flowing through this particular type of conductor. That means, what are you overcoming? I am overcoming the resistance. Itna samajh mein aaya ki nahi? Right. Analogous to this, in the last class, I had drawn one diagram that if you take a conductor in this manner, right, and this is a cross section, current or a charge can be seen as a boy who wants to make his way through this. At this moment, there is a naughty fellow sitting here and he gets sadistic pleasure. He gets a sadistic pleasure by just choking this. He will choke this. He chokes this. This fellow is known as resistance. And he starts screaming, "Mommy!" And the mummy is sitting here. The mummy is the voltage. And the mummy gives what is known as a kick. Get in. Right? Current wants to flow or charge wants to flow. Resistance strangulates, and as a result of which the voltage steps in. If this fellow does not kick, this fellow will not go. Mommy, dar lagta hai. Sometimes you say, "Na, I don't want to go there. Keep looking." Okay, I'm looking. Go now, no problem. You're looking at me now. Yeah, I'm looking. And then you start going. So the current flowing through a conductor is directly proportional to the voltage, provided temperature and physical properties remain the same. We'll write the definition. Let's change the physical properties. If you make this thin or thick, don't you think the strangulation will also change? So the resistance changes. You're not allowed to do that. You're not allowed to do that. Another thing is temperature. If you allow the temperature to grow, obviously the mobility of the electrons increases because their average kinetic energy increases. So please don't allow the temperature to grow. Or you will see if the temperature goes up, the number of collisions will go up, the resistance goes up, because if the temperature goes up, the electrons will go on undergoing collisions with one another. Are go! Kaise jaye? Road is so jammed. It's like you're asking somebody to drive speedily through old city. It's not possible. So whenever we define Ohm's law, therefore we keep these two conditions which children keep on writing. If you don't write these two, then your definition of Ohm's law gets incorrect. So let's take a first hand dip at the definition of Ohm's law. बोलते ही बस पेन रेडी हो गया सबका. Ready? Ohm's law states. So listen, and you write it on your own. Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference maintained across its ends, provided temperature and other physical properties remains the same or remain unchanged. Is this understood? Ohm's law states that the current flowing past a conductor or the current flowing through a conductor is directly proportional to the potential difference maintained across its ends, provided temperature and other physical parameters remain unchanged. Have you written this much? I will not repeat. You think if you have understood, you should be able to write. Maybe one or two has been will become had been. I don't care on those. As long as every actor is playing their role correctly. Flow of current depends upon the potential difference maintained. Obedience of a child to go and bring something from Ratnadeep depends upon how much of shouting the mother is doing. Simple, yes or no? Otherwise, if you tell Veda, go and get something from Ratna, no, not now. That's resistance. Go. That depends upon how much voltage you are applying. Is this understood? Now write mathematically. So whatever you wrote, that in mathematically we'll say V is directly proportional to I, right? Actually, we write like this. I is directly proportional to V, which can also be written as V is directly proportional to I. So V should be equal to some constant of proportionality into I, and from there you say V by I is equal to R. V by I is equal to R. Not all conductors, therefore we'll say conductors which obey such the Ohm's law are called ohmic conductors. That we will see. The metallurgy is something different. All conductors will not behave in this manner. So, I taught you y equal to mx plus c. Do you agree? I had taught you about an equation, and my equation was what? Y equals to mx plus c. How about an equation called y equal to mx? How do you see the trend of this line? Tell me, y equal to mx on a xy coordinate, how do you see? The line passes through the origin because the y-intercept is 0. Yes or no? Is it y equal to mx? What is m? Slope. What is r? Graphically, resistance is the slope of a VI curve. Learn science with advanced words. VI curve, or you call it a VI. In physics, we call it VI characteristics. Characteristic. VI characteristic means a VI curve or a VI plot. VI plot. Have you agreed? Have you understood? So let's make a VI plot. Tell me, what is this axis? X axis. If you look at this equation, what is X? I is X. So we will have current on this axis. Now kitna easy ho gaya maths. What is Y? What is Y in that equation? V. So we will plot voltage on this equation. VI. Right? And you are having the equation V is equal to Ri. So Y equal to Mx. So you expect your graph to show in this manner. And at any particular point, say, if this value is V1, this value is I1. And this ratio, V1 upon I1. V1 is Y data upon X data. Is it slope? And this slope is known as resistance. That means ohmic conductors, when he did that particular experiment, the graph should have come out a straight line. And my friend is asking, sir, what are non-ohmic conductors? Non-ohmic conductors are those conductors for which I did the same experiment. This is what is the difference in Cambridge and CBSE. Cambridge will explain this thing with a lot of experiments, and you will draw the graph and you will understand what is Ohm's law. हमारे यहाँ पे लोग रटते हैं. So for some set of conductors, we found that the graph actually did not take a straight line, but deviated somewhat like this. Obviously, as voltage increases, current has to increase. No questions asked. Because where is that diagram gone? That kicking diagram? Yes. This is a universal truth. This is a universal truth. But this universal truth may be followed as a straight line. और here we will see, पहले नहीं जाएगा, उसके बाद the mother just जाएगा कि नहीं, उस दिन दिया था ना, याद है? That day, what you got? This is, please go. So this is a linear increase. These sort of conductors will be called ohmic conductors. Now you asked me, sir, do we get ohmic conductors in real life? Not exactly. Not exactly. So say suppose copper is a very good conductor of electricity. The best conductor of electricity is who? Silver. Always remember, silver is the best. So sir, why are we not having silver wiring? We are not that honest. Not expert. Pilferage. It's not about expenditure. First of all, theft will take place. Theft. People will steal it. It's a scarce commodity. It's not about costly. Your Sony Bravia TV is also costly, but to steal it is difficult. Imagine silver wires running through highways and through forests. People will just snip it and take it away. Okay, have you understood? And silver is a scarce material. Even in silver, we won't get our experiment plots all on the same line. We will get one or two outside. This is how experiments are done. Then you should ask, sir, these 2 points didn't come on the line. My experiment is wrong. No, you are very correct. A child who shows all the points on the line has actually bluffed the experiment. Experiments are supposed to have errors. And then what line we draw? We call it the line of best fit. The maximum points. These are what we will say, these may be experimental errors. Maybe you did not take the data properly. Are you understanding? So for majority of the metallic conductors, Ohm found that they were following a straight line, and those conductors are known as ohmic conductors. Is this clear? And those who did not follow it were called non-ohmic conductors. Itna samajh mein aaya? Now, types of questions that we actually see is something like this. Okay, tell me, let's see your graph knowledge from grade 9. Suppose this is a distance and a time graph. What will the slope give me? The slope will give me speed, right? And I plot the distance time graph for two boys. One is like this, and for the other boy, it is like this. And I say, this is boy A and boy B cycling together. Whose speed is more? Speed is the slope. So whosever slope is more, you said that is he's cycling faster. Understood? Now we just change it. Are physics aise padho. This is voltage. This is current. I have two conductors A and B. Who is offering more resistance?
A.
A. No. Resistance is measure of what in a graph? Slope. Who has more slope? B. See, that's why I gave that example. You are thinking from the perspective of speed. If speed is more, means B is cycling faster. Correct. Because in that graph, the slope was talking about speed. In this graph, the slope speaks about what? What is the slope? Arey bachcha, clear ho jao. Slope is always a y data over a x data. What is y data? Voltage. What is x data? Current. Is this not resistance? I am asking whose resistance is more? The one whose slope is more. Array, why are you giving that look? If the slope is more, the R is more. Is there any difficulty in understanding this? Have you understood or not? If not, I'll again explain. Tell me, don't give me blank faces. Tell me a yes or a no. Don't nod your head. I want to hear a yes or a no. Have you understood this concept? If not, I'll explain again. No. Do you understand the slope of a graph? A slope of a graph is a measure of a y data over an x data. When I made this graph for you, I said this is distance and this is time. So what is your y data? That is something meter. What is your x data? Seconds. Do you know this quantity? This is called speed. And now I give you two plots. Whose speed is more? This speed is more. This slope is more. Sir, how did you understand this slope is more? Make a baby sit here, he is going to fall down at a greater speed. Or slope is a measure of the acute angle that it makes with the positive direction of x-axis. Is this clear? So in every graph, sometimes we will see graph of solubility, sometimes we may see graph of partial pressure. If a quantity in a graph is being represented by slope, which in this chapter, there's a quantity called resistance, which is represented by slope. So if I say more resistance, means more slope. Is this understood or not? If it's more resistance, means more slope. Because in this chapter, slope is representing resistance. Have you understood? So between these two conductors, who offers more resistance? This one offers more resistance. This one offers less resistance. I want more current to pass for my experiment. Which should I pick? A. A is a more obedient child. B is a more disobedient child. Is this thing getting clear? Now let's see a question which comes very common in Phoenix Green. Okay. And many children used to make it wrong. There, they used to do a very tricky question. Two conductors A and B, which is offering more resistance? Now B is offering more resistance because you should look at the graph. The graph is not VI, it's an IV graph. And all children 3 years or 4 years back went and wrote, A offers more resistance. From that day, I used to love this question. A offers more resistance. No, they have tricked you on the graph. What is resistance? V upon I is resistance. In this graph, slope is measuring what? I upon V. So you are measuring 1 upon R. Are you getting it? So for A, 1 upon R is more. Have you understood? That means B is offering more resistance. This question is very common in pre-boards. So whenever such a question comes in graph and they tell you which has more resistance, immediately don't answer. Resistance is the slope of what graph? VI graph. Sir, I forgot which axis, what was there. Y equal to mx plus c. How to deduce? No voltage, no current. Mother has not made any request. Why should the child go to Ratnadeep? That means no voltage, no current. If x is equal to 0, y is equal to 0. That means in our equation, it will always be y equal to mx. There is no c. It will always start from the origin. Okay, y equal to c. Sir, m is slope. I knew resistance is slope. V by I is equal to R. I know that. So V by I is R. That means V should come here, R should come here, and I should come here. My graph, V should be on Y axis, I should be on X axis. समझ में आया? Clear? So what all did we discuss? Ohm's law. I could have just told you the definition which I'll be doing in the next round of revision. What does Ohm's law states? Ohm's law states that the current flowing through a conductor is directly proportional to the voltage difference or the potential difference maintained across its ends, provided temperature and other physical parameters remain the same. Right? Temperature and other physical parameters remain the same. Conductors which behave this law are called Ohm's law. And from this, mathematically, how do we say? I is directly proportional to V. So V is directly proportional to I. So V is equal to some constant into I. That constant is called R. Understood? So V is equal to IR. This is your new equation that you have got today. So how many equations? We have not done any numerical so far. So we used to say voltage is always work done upon charge. Current is always Q upon T. V by I is equal to R. V is equal to IR. This has come from here only. So these are the new equations that you have learned. Also, you know, potential difference delta V is always final potential minus initial potential, which is the work done by the external source to bring a charge from A to B divided by the charge value. These formulas should be all in your lips. Correct? So let us now define resistance. R is equal to how much? V upon I. Correct? So if the value of V is 1 volt and I is 1 ampere, then R is supposed to be 1 ohm. 1 ohm. And an ohm's representation is the Greek word omega. Omega. Right? So let's define 1 ohm. Define 1 ohm. So how do you define? Look here. The resistance offered by a conductor, is said to be 1 ohm when a current of 1 ampere flows through it when its ends are maintained at a potential difference of 1 volt. अगर 1 volt के potential difference में 1 ampere current दौड़ के चला जाता है, then that conductor is offering a resistance of 1 ohm. What is 2 ohm? The resistance offered by a conductor is said to be 2 ohms when a current of 2 amperes flows past its cross section with the potential, no. When a current of 1 ampere flows, obviously, how can 2 ampere flow at 1? Resistance is 2 ohm means less current should flow, na? Dimag lagao. When a current of 1 ampere flows and you are supplying how much of PD? 2 volts. Then the resistance is said to be 2 ohms. 2 ohm means it is a more stubborn child. 2 2 ohms means the strangulation is more. So if you want the same current to go, double the voltage must be applied to it. This diagram makes everything clear. So is 1 ohm clear with everyone? What is 1 ohm? 1 ohm is said to be the resistance offered by a conductor when a current of 1 ampere flows past its cross section, when the ends of the conductor are maintained at a potential difference of 1 ohm. Understood? Okay. So we are talking about something called resistance. So resistance is something like a phenomenon, a behavior. Who shows this behavior? A conductor shows this behavior, not a bad conductor. A bad conductor, first of all, does not conduct at all. Very bad. A conductor conducts. My child is obedient, but there is a disobedience factor there in my child. You are studying that disobedience. So the conductor who will show a resistance later on, that conductor we can call also as a resistor. Honesty, honest guy. Honest guy shows honesty. So in market when we go and say, bhai, 1 minute beta, bhai, 800 ohms ka resistance dijiye. Wrong word. Get some labor and ask them to do that garden job. Get some laborers. Laborers will give their labor in exchange of money and do your work. In a market, as an engineer, you buy resistors. They will offer resistance in the circuit. But when you go to the market, they'll all say, resistance hai resistance. Hey, you have resistance with your resistance hai aapke paas? Yeah, Shreya, your question.
Can you just repeat the definition of
No, I will not repeat. You see from here and you say, what is 1 ohm? What is 1 ohm? This diagram should tell you. Where is my diagram? Where is the diagram? No. I will not say this diagram. If I maintain a potential, listen once again. If I maintain a potential of 1 volt, means the mother is screaming with 1 volt. 1 volt. Go to Ratnadeep, 1 volt. How many amperes go through it? 1 ampere goes through it. At that time, the child is said, you have such a nice girl. She is offering a resistance of 1 ohm. So how do we say it in English? The resistance of a conductor is said to be 1 ohm. No. The resistance offered by a conductor is said to be 1 ohm when a current of 1 ampere flows past its cross section when the ends are maintained at a potential difference of 1 volt. Yeah, the more the mother screams, the more the number of current will go. But this is the ratio. The ratio is something like this. Where's my diagram? This.
Sir,
Yes.
this is a resistor, right?
Which one? Yeah, that is a resistor. It will have some color code bands on it. Yeah. With that, we actually find what is the value of the resistor. If you want that, we can tell you that also. Yeah. So here what happens? Suppose you have not changed the dimensions and all, or the geometry, you have not made it mota or patla, whatever, then this particular shape will have a strangulation. Strangulation. This strangulation will not allow the current to go through it as handsomely as you were expecting. At that time, you have to give a kick. The kick is always given by the voltage. Why is high voltage dangerous for you? As a human being, you also offer resistance. The human flesh offers a resistance of the other day. I told you, I gave you one question. You remember? Yes. I told you that the ceiling fan, which is rotating on my head, draws a current of 0.65 ampere. Whereas the mobile charger and the wire which comes out with the pin, we say that this is a 2 ampere charger. You touch this with your naked feet on the floor, nothing happens to you. Nothing happens to you. But if you just touch this 0.65, you will become photo on the wall. Because 0.7 to 1 ampere is lethal for a human being. What is the thing that is where the mathematics is not fitting? The mathematics is not fitting because it is something like this. You are a human being, right? And this is the ground on which you are standing. there is a particular amount of current which is trying to go through your body, right? 0.65 goes through your body and you are dead. That means I can say that you died when 0.7 ampere was going through your body. It is a truth, right? At this condition, we are dead. There is another scenario where you have connected the mobile cable to your body and you are saying, sir, 2 ampere is going through my body. Why am I alive? दो चीज तो हो नहीं सकता है ना. Somewhere someone is playing a game with you. This is universal truth. 0.7 to 8 ampere, you will die. That means there is something wrong here. 2 ampere cannot enter my body right now. If 2 ampere was entering my body, I would have become a sandwich by now. Ekdam crispy. What is the difference? My body also offers, the human flesh also offers resistance. It will not allow current to pass. The human body will offer a resistance of around 10,000 ohms. 10,000 ohms when we are in dry condition. Take a bath and don't wipe your body properly. At that time, you are wet. At that time, your resistance of the body comes down drastically to 5,000 to around 5,000 ohms, almost half of it. Understood? What you are not concentrating on these two is that the voltage in this case is 220 volts, whereas the output voltage of any USB device is only 5.1 volt. This is universal standard. Any USB device, why do you think? किसी भी मोबाइल से कनेक्ट कर लीजिए, any charger you connected. Every USB device, USB is known as Universal Serial Bus Controller. And the worldwide spec is that it will only offer an output voltage of how much? 5.1. 5.1 volt is sufficient for your mobile phones to drive 2 ampere. Your mobile phone is a very good conductor. All circuits are there. It cannot be a resistor. 5.1 volt is not sufficient to make 2 ampere pass through your body. Have you understood? You will die at 1 ampere. That is a truth. So for 1 ampere to go through your body, what we have to do? We have to counter your body's resistance. Oh, same diagram. 1 ampere to go through your body is offering great resistance. And at 1 ampere, you will die. So what do? Increase the voltage. So whenever you touch AC mains, 220 volt is coming to your body. 220 volt is sufficient to drive 1 ampere through your body to die. Is this example understood? The mobile phone's output is only 5.1 volt. 5.1 volt can drive 2 ampere through my phone, not through my body. Because my body is very stubborn. Whenever it sees 5.1, 5.1 is like what, mother, you know? खेलने दीजिए ना बच्चों को. They're so cutie babies. Let them play. I don't force them. Saturdays I want them to wake up at 2 o'clock. Why we have done so much? Let them enjoy. Beta, bachcha khelo, bachcha. No, bachcha. So my body sees 5.1 like that. So will it allow 2 ampere to pass through my body? No. But 220 is like what? Yeah. It is that, mother. Immediately 0.7 ampere goes through my body. And we die. Have you understood? Concept cleared? Some more examples like this which will open your mind. How many of you understood this example? Why the mobile phone charger does not kill you? So you will say the mobile phone charger does not kill me because the output voltage of the mobile phone charger is not sufficient to drive around 1 ampere through my body. Why are you considering 1 ampere, Ananya? Because 1 ampere is sufficient to be lethal for a human body. If 1 ampere goes to your body, you will die. That's a truth. But your body's resistance is very high. For 1 ampere to go, you have to give a very big kick. That kick is available in the plug point, not in that battery. And just put 220 volt directly into this mobile, this will explode. Yeah, isn't?
Sir,
Yeah, 1 minute, I'll take her query and then isn't current V by I is equal to R. V by I is equal to R. So V is so you're trying to find out current. Current is voltage by resistance. Yes, correct. If the resistance is more, the current through your body is less. But the resistance of your body is fixed, little bit high. It is fixed. Fixed hai. Now you want more current to go through your body. You can't tweak this. I want more mangoes per boy. Number of boys is 24. I want more mangoes. I can't reduce my boys. So what do? Increase the mangoes. Increase the voltage. You die. ठीक ना? हाँ अनुराग बोलो.
So it's basically like that 5.1 volts is not able to give the 2 amperes like enough of
5.1 volt in my body will not give you do na. Your body resistance is around. Yeah, what nonsense this boys are. V by I is equal to R, correct? So V by R is equal to I. So 5.1 divided by 10,000 is my body's resistance. The current flowing through my body is now 5.1 into 10 to the power minus 4. Very, very less. तो अभी 220 नहीं ना, अब करते हैं ना 220 divided by 10,000 0.022 10,000 से कम होता है. That might be an arbitrary factor. It's around 5,000 if I'm not wrong. Let's do it for 5,000. Say 240 divided by 5,000. Okay, so it will come around 0.048. You'll feel the jhatka. Again, around 4,000 to something. And when we are wet, the resistance falls down. So at wet condition, the chances of you to die are much more because your body's resistance has reduced. Current will immediately go through you. Now the next question, some important questions now, because if these things are clear, then only you will understand current electricity. Where is my, okay. Second question. These are electrical wires which are running from Anurag's house to our house in Pebble City along the ORR. He is in Prestige near Continental and this is Pebble City. There are, Chunnu is sitting here and these are carrying around, these are not even 220, 440 line. Chunnu is here, Munnu is also sitting here. Nothing is happening to them. Why? Sir, birds are bad conductor of electricity. Nothing is happening to them. ऐसा करो ना तो मजा आएगा. Has these examples been discussed in your school? Anurag बोलो नहीं ना. अच्छा चुन्नो मुन्नो, do they get electric shock? No. But have you gone to नहीं आ रहा all these wires are naked, huh? They are absolutely naked wires. इसको कोई रबर नहीं लगाता है. इतना धूप गर्मी में थोड़ी रहेगा. अच्छा, do you know an animal called bat? Chachundar. Have you seen in villages and all bat hung on electric wire? मरा हुआ पड़ा है. Okay. We do see bats dying due to electrocution, but pigeons are not dying. Dove is not dying. Parrot is not dying. Why? Some Brahmadev gave some, तुम अमर रहोगे, ऐसा है क्या? वो क्यों नहीं मरते हैं? So shall I add more bit of humor to it? So we kidnap Anurag out of his house, and we are now putting Anurag out here. Spider-Man. Anurag is now hanging on this, okay, on this wire, and this wire is absolutely 440 volt. Anurag is hanging both wire in the street of light. He arrives just in time. Anurag will be alive. कुछ नहीं होगा उसको. क्यों? This is 440, or sometimes these lines are also 13 kV. Do you know what is 13 kV? 13 kilovolt. And the electric train, Shatabdi and all, have you seen that thing? Oh, what is that called? With the Pentrax? No, I'm not getting the words with a P. Pentaloop, or what is that device which goes and strikes with the engine will strike it on the pantograph. That's called a pantograph. So whenever an engine starts, the pantograph will open and it will just go and stick with that current. Have you seen that in any railway station? It will create a huge spark. That is 25 kV. Even if you sit on the engine also, you will be pulled up. So I have put Anurag, I'm hanging Anurag now on 13 kV. Nothing is happening to him. Why?
because there's less current flowing.
The voltage is at 220, you will be fried. Now one example, take it. I mean, you all are all grown-up children, so there's nothing. Anurag, excuse me for this example. At that moment, Anurag drank a lot of water before I made him hang, and then Anurag has released. Right now, he will become sandwich. Immediate. Have you seen 3 Idiot first scene? मूत्र विसर्जन कीजिए. Salt water is a good conductor of electricity. All these we had learnt in grade 8. What is the difference between this and this? Current has to flow through the body of this boy. In the first condition, the current is not flowing through his body. Okay, let me make this example a little bit more civic and sober. 1 minute, little bit more sober. Now I'm standing here, or his best friend Ali is standing here, and he says, "Yaar, tera juta kitna acha lag raha hai," and he touched him. Both will be fried in one moment. Because the current flows through his body to the ground. Earth always wants current. That's why we do earthing in house, which we will read later. Current always flows to the direction of lowest resistance. Earth offers very low resistance. We all have earth wire in our house. The central plug point is the earth wire. And our friend was standing where? On earth. And he just touched Anurag. Circuit complete? Complete. Why does a bat get electrocuted? Bats cannot see. Bats communicate with ultrasonic sound. At night, the bat might have flattered its wings, and accidentally some wing must have touched on the other wire, as a result of which the bat got electrocuted. Some harsh videos, but you'll sometimes see that some langur or monkey has gone and is hanging on a particular electrical wire, and people are desperate to save that, because the monkey thinks, how do the monkeys maneuver? Branch to branch. He sees the other one as a branch. There are many such videos, disturbing videos. And once the monkey holds this and holds another, immediately he will be electrocuted. He does not know this knowledge. But the pigeon does not have long, slender legs to spread apart between two wires. So the pigeon always sits on one wire only. At that time, if the pigeon was puking and the puke touches any other wire, pigeon will also get fried. Do you understand now the concept? Which means, say suppose there is an electrical wire and you are a person and you are wearing ultra high grade safety boots, then you have disconnected yourself from the earth. As a case mein, you can go and touch the live wire also. Nothing happens. When I joined my plant job first, in my job shift duty, I was also given safety boots. And my first thing was to test it, whether they work or not. So you know the tester screwdrivers? So tester screwdrivers will do those experiments. You can put the tester screwdriver into any of the plug points and wear your slippers. You will see the glow is less. Remove your slippers and touch it. You'll see the glow increases because more current is flowing through your body. Or at that time, you wear slippers, but say I make Atreya hold my hand and he is barefoot, more current will be flowing through it. That's why when a person receives an electric shock, don't ever touch that person. You are supposed to take a bamboo and hit him. Don't touch. If you touch, have you seen that Havells ad? Shock laga, 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 one after the other. That happens because human beings will all conduct electricity. And when the electricity is at that place. Is this clear? So this myth is clear. Yeah. Somebody wanted to ask a question here. कोई कुछ बोलना चाहता था. बोलो अमिश, somebody was having a question.
मैं तो ये कहना चाह रहा था कि जो पैर होता है वो एक ही बार में आ गई.
हाँ, एक ही बार में, 2 बार में आ गया तो हो गया, मर गया. Spot, you will go. So if you wear safety boots of proper grade, you can actually touch live wire and you can do. But at that point, make sure neither your elbow touches anywhere, you touch anywhere, somebody comes and touches you, and you're gone. So electrical jobs are always done in isolation. मरो तो तुम मरो, और एक आदमी मरना नहीं चाहिए. Okay. One more example, interesting this one, and after this we end the class. Okay, very nice. So this is a very nice example. So we have our friend Shreya out here who has come on a birthday party to say at PBL City, at our place. She's come on a birthday party. She did not carry her charger. Her phone has a OEM. OEM, you know, original equipment manufacturer. So her phone is marked with a 2 ampere charger and she has come to Pebble City and she did not bring her charger. Understood? And another friend also has come. Let's say Anurag has also come. His phone is actually marked with a 3 ampere charger. Originally means Shreya is supposed to hear me now?
Yes.
Okay, so Shreya and Anurag have come to Pebble City to attend a birthday party. Shreya is carrying a phone which needs a 2 ampere charger. Anurag has a phone which has a 3 ampere charger. Both are coming with low battery to our place. Both are not carrying their chargers, right? And they come to my house, right? And in my house, I have got a choice. I've got a 1 ampere charger and I have got a 6 ampere charger. A 6 ampere charger. And I'm offering the 6 ampere charger to Shreya, whose phone charges with the 2 ampere charger. Should she charge or not charge? I want no nodding heads. I want answers. And her phone is very costly, huh? Should she charge or no? Majority I heard that she should not charge. No is the answer I found. Okay. And I gave the 1 ampere charger to Anurag. Should he charge? The majority answer I heard was a yes. Fools. Super fools. Shreya's mobile will be charged very quickly. Anurag will wait the whole day. His phone will never be charged. Please understand. Both are mobile chargers. They have got USB output. So both are giving me how much? 5.1 volt as per international standard. First check this. As long as this is 5.1 volt, tension is not there for any damage. Now there can be one thing. I can get a fit to fit charger. I can get an overfit charger or an underfit. Both the boys and girls are not getting fit to fit. One is getting an overfit. A more current is something that you draw based on your capability. Shreya's phone draws how much? 2 amperes. No matter you give Shreya a 12 ampere charger, she will draw how much? 2 amperes only. But this fellow's phone draws how much? 3 amperes. And you are connecting it to what source? 1 ampere. To see this example better, my mother has got a gas stove which has got 2 stoves in it, 2 burners in it. And Aryash and Ananya have come to my house. My mother is making rotis. Will she be able to meet their demand? A normal Indian lady will be able to. Auntie roti, auntie roti. They consume say 1 roti every 1 minute. By 1 minute, my mother will be able to make it. So this charger can drive them. But the entire 17 of you came to my house. And my mother is making roti in this. हाँ बेटा लाता हूँ बेटा लाता हूँ. My mother will be red. So when he connects his 3 ampere to this 1 ampere, this charger will become warm and hot. But it will not charge him. But my mother is making very good quality rotis. But she is unable to meet the demand. But I took 14 of you and I took you to a Gurudwara, Langar time. How many people sit in a Gurudwara batch? 200? 300? You all are 14. Will they feel any pressure? Puri Vaheguru, ye de 3-4 ko de diya, bas khatam, better रहेगा. So the 6 ampere charger for Shreya is like a Gurudwara. Girl is going to eat only 1 roti. Take it. Never be afraid to connect to a high current source. So question again comes, do you know jump starts? We jump start our car. Lagega time, thoda 5 minute do. Car batteries are all 12 volt. Whether you are a car or you are a truck, 12 volt. The truck battery has more higher ampere. The car has a low higher ampere. Within cars, I have got a sedan and I have got an Alto. Should you jumpstart the sedan with the Alto? Never. Never. Mother gives birth to baby. Baby doesn't give birth to mother. So there are some idiots here. You will find just because I have a jump cables. One day a guy came and told me, jump cable देना जेडी भाई. तो क्या हो गया? गाड़ी बंद हो गया. कौन सा गाड़ी? XUV 700. I said, with whom will you jump? No, my colleague friend has come. What is his car? Santro. He is trying to jump XUV 700 from Santro. The Santro will in 1 minute drain off. Did you understand? The Santro's capacity is less. But if it was the other way around, can the XUV jump the Santro? Yes. The XUV should be jumped by similar vehicle, Scorpio N, or jump it with a truck. Mother to baby, not baby to, both are 12 volts. But the current capacity of this one is more high. This is a langar and these are 2 babies. And if you do the other way, you are trying to feed 14 children with my mother. My mother's quality is good, but she cannot, her withdrawal rate is not high, and you want, auntie, roti. So Shreya can easily charge with 2 ampere. Get this concept out of your mind. Nothing will happen as long as this is okay. Rather, her charging will be very fast. Wow, sir, at your house my mobile charged so quickly. Have you heard the word called fast chargers? Fast chargers are all chargers whose amperage is more. Fast chargers are like langar. And you went, mujhe thora khana denge? Ha. You open one casserole. What does he do? And slow chargers are like pujari of the temple. Sir, thirsty. You'll never get charged. मजा लेके पढ़ो. आज Ohm's law पढ़ लिया, resistance पढ़ लिया. अगले क्लास में we will see one more thing. What makes them stubborn? Slowly we will go. Get lost. Any questions if you have, you can ask. Oh, yeah. You must be thinking why this man is not going. He's gone.